We're glad to have all of you here this morning. I'm Robert Cooper, Coordinator of Sciences and Mathematics. We're especially glad to have many of the school groups here. I believe people from Marion and Fairmount and other locations. The members of our science department are always pleased to welcome all of you to this type of a meeting. This really is our 8th annual science lecture and discussion series. We wanted to mention, though, that the science departments have some especially outstanding educational opportunities for students and staff and friends to participate in during the school year. And some of those come up yet this spring. We'd want to mention to you that the planetarium and the observatory in the new Physical Science, Mathematics, and Nursing building over across campus have been opened on school days for the pupils of Delaware and surrounding counties, and also the planetarium and observatory have been open on recent weekends to our community. We'd want to mention, too, the science fair, the regional science fair, to be held the weekend of Saturday, March the 30th this year. This gives you, of the student body here at Ball State, and interested persons from several surrounding counties, a chance to see samples of public school science activities, ranging from kindergarten through the 12th grade. The exact deadline we want to mention, though, we're going to try and stick with it very carefully this year, will be March the 13th. So those of you who are interested in science fair, regional science fair here at Ball State, be sure to get in your entries. To get those entry blanks, if you do not have them, write to Dr. George Welker, Department of Biology. Dr. George Welker, Department of Biology, Ball State University, zip is 47306. And our 2 seniors this year who win that, along with their sponsors, will be going to Detroit, Michigan for the 19th International Science Fair to compete with the winners from other regions. Then we want to mention one other that several of you will be interested in. On March the 21st, we'll have the dedication of the new Physical Science, Mathematics, and Nursing building. And throughout the day, there'll be special guest scientists will be appearing as lecturers in each of the subject matter fields that afternoon, starting at 1 o'clock and going on through. And those meetings will be over in the new Physical Science and Math building. The dedication lecture for March the 21st will be in the evening and will be given by Dr. Werner von Braun of Huntsville, Alabama. We will welcome you. There's no charge at all, and we'd be glad to have you. Our lecture and discussion series this morning starts the current science lecture series held annually in February. And our science staff, we'd like to repeat again, believes that this helps us all to be a little better informed concerning current science developments and helps us to build a respect and interest in all branches of science, and also helps us to have personal contact with some of our outstanding scientists who, even though they are with us just a short time, help us to catch a bit of their enthusiasm and inspiration and encouragement. We want to encourage you to attend not only our daytime sessions, but the evening session tonight. We'd like to remind you that all of our lectures are held here in the Emmons Auditorium, and some of the discussions which follow will be held at other locations and be announced as we go through the program today. There are lectures here this morning at 9:10 and 10:10, this afternoon at 2:10 and 3:10, the discussions this morning at 11:10, and this afternoon the discussion being held from 4:10 on. It's a genuine privilege for all of us to work together on such a project as this, and we want to especially thank our committee members, Dr. George Beatty of the Department of Geography and Geology, Dr. William Bach of the Department of Physiology and Health Science, Dr. Leon Reynolds, Department of Physics, Dr. George Welker, Department of Biology, Dr. Robert Shelley, Department of Chemistry, who has served as co-chairman on the committee, and Dr. Russell Siverly, chairman of last year, who has served as advisor to the committee throughout this season. We're very grateful to all of them for their help and their cooperation. Dr. George Beatty, head of the Department of Geography and Geology, will introduce our first speaker this morning, Dr. Beatty.
Thank you, Dr. Cooper. The Department of Geography and Geology welcomes you to the first session here of the program. Students and staff and visitors, I know there's some visitors who've come some distance here in order to hear our session this morning. Appreciate their coming with this weather as bad as it is. And we're very happy to have as a representative for our department in this program a man who has something to do with the weather, at least can talk about it. He's a meteorologist. And if you look in your brochure on the second page, you'll find his picture and a description, an account of his experiences, some of his experiences. And particularly, right now, he has a job dealing with storms. He's director of the National Severe Storms Forecast Center at Kansas City. Came in yesterday in a small plane underneath all this heavy cloud cover, and he made it. His topic for us, I think, is very pertinent to this part of the country, and you'll note the topic in your brochure again, because where we live here, we have many storms, many of them quite severe. So to talk about the case study of a tornado outbreak, I present to you Mr. Alan D. Pearson.
Thank you, Dr. Beatty. The last time I was in Indiana was a less favorable time. It was 3 years ago when Indiana and the Midwest was so hard hit by the Palm Sunday tornadoes. And also in that time was by a light plane flying along the tornado tracks that went from, as I recall, from Lafayette to Kokomo, Roosevelt, and on, I believe, north of this area. So it's a little more pleasant to be here under these circumstances. As far as it being bad weather, a weatherman defines bad weather as being anything that's not correctly forecast. And I find the weather delightful today because I know it was forecast. I would like to talk just a few minutes and then go into some slides and later a movie that we have. In the year that just passed, there were over 800 tornadoes in the United States, ranging all the way from Hawaii to Maine. And I believe about 100 people were killed, which is about the average number for the year. The last big disaster we had was 3 years ago when 270 people died. I believe some 150 or more in Indiana. And through the past 15 or 20 years, the incident of tornadoes seems to be increasing. I'll dwell on that a little bit later. But fortunately, the number of deaths are going down. We like to think that we have had a little bit to do with reducing the deaths. I'm sure all of you have heard the tornado watch, where the Weather Bureau says there's a possibility of tornadoes 60 miles either side of a line from Kokomo to some other place. And we get kidded quite a bit about the incident of tornadoes that do happen because it seems to many people that we cry wolf. We can illustrate this with Kansas City is in the heart of Tornado Alley. And some years ago, we issued a tornado watch, and about 6 hours later, I received a call from a very irate little old lady. She said she'd spent 6 hours down in the basement and nothing had happened, and she was mad. She was really mad at me. Well, I explained to her that we did the best we could, and we were happy that nothing had happened. And so a couple months later, we went through the same process. And once again, she called up, and she was really furious this time. 7 hours in the basement, huddled in the southwest corner, nothing. Well, I explained to her that it was for her own protection, but she didn't want to listen. So finally, on the third time we had a tornado watch, she went down to the basement. When she came up, the house was gone. So she gave me a call on the phone, and she said, "Now that's more like it." If I could have the house lights off, please. I'd like to show a recreation of the tornado that struck Topeka in June of 1966. This tornado was the single most destructive tornado we've ever had in the United States, doing over $100 million worth of damage as it passed through the very heart of this town of about the size of Muncie. But we had issued a tornado watch some hours earlier, and while there was over 1,000 homes destroyed, the death toll was only 16. So through this, I would like to show you how we went about it. May I have the first slide, please? And the next one, please. First, just a recap. May and June are the very heart of the tornado months for the country. And though it happens in Indiana, you had your worst disaster in April. After June, it starts dropping off rather rapidly. Next slide, please. We make use of the terms watch and warning in our program. The watch means that you should be alert that things might happen, but you can go on about your normal business. When you hear the word warning, it means a tornado has actually been sighted and some kind of precautionary measure is needed. The next slide, please. Tornado Alley runs from North Texas up through Oklahoma, eastern Kansas, and then one branch comes right through Indiana with a secondary maximum through the Southland. Actually, in the spring, the tornado maximum starts down in Louisiana, Mississippi, Alabama, and moves northward with summer. And then as fall comes, it moves back down in this direction. By states, Texas has the greatest number of tornadoes, mainly because of the sheer size of the state. Oklahoma has the greatest number per square mile, and Kansas is second. However, in the past 2 years, it seems to us that the Tornado Alley has shifted to practically to Illinois. We've had our biggest activity through the central plains. Next slide, please. This is the interior of our office in Kansas City. Shows the various types of weather maps that we have on the wall, and the two of the forecasters working, and it just kind of sets the scene for the story that's to come. Next slide, please. That morning, the man on the right had been on the midnight shift, and he had prepared an outlook of potential tornado activity for the central part of the country. He was briefing myself and the duty forecaster here about the way things might go. But this is sent out on a facsimile machine, which is similar to the wire photo you see in the newspaper, and sent out to various Weather Bureau offices in the country so they can know how to prepare their day. However, we have upper air balloons that go up to about 100,000 feet are taken every morning at 7 o'clock Eastern Standard Time, and we wait for the results from them before we start actually making the specific forecast for the day. The next slide, please. By 8:30 Central Standard Time, 9:30 your time, the data was starting to come back from the various upper air soundings, and the forecaster was beginning to get a three-dimensional look at the weather across the country. It's a process of literally kind of a jigsaw puzzle, if you will, to putting things together so that he can know the moisture, the winds, and the various meteorological parameters throughout the atmosphere. Next slide. To help us, we have a Control Data Corporation Model 3100 computer that handles about 1 million bits of information daily and acts as a gigantic sieve or filter so that the forecaster is not forced to look at weather information from all over the country. Rather than gleaning each report as it comes in, we have instructed the computer to print out those things that we've found to be key items so that we can bring them immediately to his attention. So about 10 after 9, the data was starting to be processed by the computer. Next slide, please. The surface chart for 6 o'clock that morning showed a low-pressure area in the Texas-Oklahoma Panhandle. Now, low-pressure areas are very common. We have them day in and day out, and it's not enough to forecast tornadoes just for a low-pressure area. So there are several other things that the forecaster looked for. One of the key elements that we found is an intrusion of very warm, moist air that generally comes in from the south. And this was present. This, for example, is the temperature. The temperature was 73 in the warm air. And so there's two items were already there, the low pressure area and the warm air. But we're also concerned about the moisture. And this temperature, I believe that reads 68, I think that's the same, is what we call the dew point. It's a better indicator of humidity than the relative humidity that you hear, since the relative humidity is controlled by the outside air temperature. But what this may be likened to is that if you had a glass of Coke and you cooled it down to 68 degrees, you'd start getting the condensed water on the outside of the glass. And the higher the dew point, the more moisture there is in the air. So the forecaster had found three things that he was looking for. Another thing that we have found essential to a tornado process is the intrusion of warm but much drier air into the low pressure area, generally from the west. And this is shown in red. Whereas the temperatures are, I believe that temperature reads 70, are still quite warm. The dew points are much lower. They're running in the 30s and 40s in New Mexico and Arizona. So coming in from the west along this line was this very sharp boundary between the dry air and the moist air. So once again, another of the key parameters was present. Coming in from the north was a supply of much colder air. Temperatures were in the 40s and 50s. And here is the cold front that separates the two different air masses. So on the surface map, all of the things that we look for were present. The yellow, it happens to be areas of fog, and the stippled areas of rain, but they were of no consequence. By coincidence, there was a hurricane coming in along the west coast of Florida, but again, that just was a mere coincidence. Next slide, please. So after examining the surface features, you found everything you look for. So the next step is to check the map for 5,000 feet. Once again, we look for much the same type of thing here. We look for a moist tongue of air coming up generally from the south, and this was present through central Texas going up into Oklahoma and into Kansas. Mind you, here is Topeka, here. We also look for the warm air coming in from the southwest, and that axis ran from West Texas up into the Panhandle. These temperatures are in Celsius. The 24 converts out to about 75 degrees Fahrenheit. The third thing that we feel that we must have at 5,000 feet to produce tornadoes is strong winds, generally from the south or southwest. Now let's take a plotting model so you can get a feel for it. At Little Rock, each one of those lines is equivalent of 10 miles an hour. So I believe there's 4 lines and a half one, so the wind is blowing 45 miles per hour at the 5,000 foot level. And Oklahoma City had about that velocity, as did all the winds through Texas. So again, at 5,000 feet, everything we were looking for was present. Next slide, please. The next level we check is the jet stream level. The jet is a band of high-speed winds that generally circles the globe. The altitudes can vary from anywhere to 30,000 feet to 45,000 feet, depending upon the latitude. And many times, for reasons that aren't too completely clear, the jet stream will split. In this case, the jet stream was known to come in from the west, with one branch coming across central Kansas and going through Peoria, another splitting and going up over Minnesota. Again, for the sake of the plotting model, let's take that St. Cloud report. The triangle is 50 knots. There's 2 of them, and so I believe the wind is 125 knots at St. Cloud. At Topeka, the wind was blowing 75 knots. At Peoria, 100 knots. We have found that where the jet stream splits, that this is very favorable for the development of low-pressure areas at the surface. What it does is that air is actually depleted at the higher altitude faster than it can come together at the lower levels, and the pressure falls as a result. So the forecaster had found everything that we feel is essential to the tornado process. And he put them all together on the next chart. Next slide, please. This was a composite of the various things that we're looking for. The low-pressure area in the panhandle, the jet stream coming up here, the warm air at the surface, the warm air at 5,000 feet, and it just kind of made it a mishmash. We have various key parameters spread all the way from New Mexico into central Missouri and from Texas into Nebraska. Now, it would be very simple from our standpoint to say, well, there's a possibility of tornadoes in northern Texas, Oklahoma, Kansas, eastern Missouri, and what have you. But we found of the various things that we're looking for. The low-pressure area in the panhandle, the jet stream coming up here, the warm air at the surface, the warm air at 5,000 feet, and it just kind of made it a mishmash. We have various key parameters spread all the way from New Mexico into central Missouri and from Texas into Nebraska. Now, it would be very simple from our standpoint to say, well, there's a possibility of tornadoes in northern Texas, Oklahoma, Kansas, eastern Missouri, and what have you. But we've found that if we were to do that, people would pay absolutely no attention to it at all. So the role of the forecaster is to try to resolve these parameters and to forecast them ahead in time and space, and to come out with a tornado watch area for as small as possible area as possible. So the next chart, the next slide, will show the forecast that the man made for 12 hours later. Next slide, please. He forecast the low-pressure area to move from the Texas Panhandle up into eastern Kansas. The jet stream was forecast to remain virtually stationary, and the low-level moisture and the middle-level moisture were shown to be coincident. To him, this gave him everything that he felt was vital to the tornado process, and the crosshatch area is the forecast tornado watch area that was issued. All of this took him about 2 hours' time to put together. And if I have the next slide, please. At 10:45, he felt that he had sufficient evidence to go out for the issuance of a tornado watch. Now, mind you, at that time of day, there were no thunderstorms in evidence anywhere in the central part of the country. His problem is compounded first that he has to decide whether thunderstorms will develop or not, and then if he does feel thunderstorms will develop, he has to decide whether a few of them may turn into tornadoes. So it's almost like trying to shoot something around the corner, because you take a known entity like a hurricane, which is fairly easy to forecast. It already exists. But the problem with the tornado is many times the tornado watch area has been forecast, has been issued long before the thunderstorm that will become the tornado has even been born. So next slide, please. At 11 o'clock, our communication unit had sent the message out all over the country, alerting all interests of the possibility of tornadoes in eastern Kansas and western Missouri between 2 o'clock that afternoon and 8. Next slide, please. From here on, our part is done, and the local Weather Bureau station starts watching the sky with the radar to see the development of clouds and to look for certain characteristics in the cloud. The radar sends out high doses of energy in very short pulses. The radar energy goes into the cloud, is reflected back or refracted back to the radar set from the inside of cloud droplets or by ice particles in the cloud, and by measuring the length of time that it takes for the energy to return to the antenna, we are able to determine the distance the cloud is away. Basically, the stronger the cloud, the more water content in the cloud, the stronger the signal is. It would be similar to sending an echo or a shout from your voice against a nearby wall. The closer you are to the wall, the more return you get. And so the next slide, please. This is the way if a tornado will look on radar. We call it a hook echo, some call it a figure 6. We don't actually see the wind with the type of radar that we have. We see the cloud droplets, and we can see the definite circulation. This happens to be the radar is located in this, let's pretend this is Indianapolis radar, right in here, and this is a reflection from the buildings in the town. And the white then is the parent thunderstorm. The bulk of tornadoes are on the south flank of a major line of thunderstorm. Not every tornado has this look on radar, but if we do see this hook, we will sound the alarm regardless of whether we've had a visual sighting or not. So next slide, please. Here are 4 time-lapse pictures taken of a tornado showing the sequence of events. And we have it in backwards. Next slide, please. So the Kansas City happens to be only 50 or 60 miles away from east of Topeka, and this is our radar set. Because Topeka has a problem with the ground clutter or the return from their own buildings, and similarly we have the problem within our own, we correspond back and forth with them and using a special radio. And at 2:20 in the afternoon, our radar operator picked up the first evidence of the line of thunderstorms starting to form in central Kansas. This was nearly 3.5 hours after the tornado watch area had been issued, and some 8 hours after the initial weather data had been taken. So this was detectable both on our radar and on Topeka's. Next slide, please. By 5 after 6 in the evening, the heavy squall line was very visible to us and to them as well, and they had positioned their volunteer observers, the highway patrol, the sheriffs, the citizens band radio, and the various groups that voluntarily act as a protective ring around the major cities in Tornado Alley. The storm struck the town at 8 minutes after 7, as I recall, and was detected from a mound outside the west of the city. Like most Midwestern cities, Topeka had its own Indian legend that said they weren't going to be hit because in this particular case there was a large hill on the west side of town and the tornado would be diverted around it. I believe that Muncie has its own legend too. I'm told that you have a bend in the river or something, do you? Since the probability of a tornado hitting any place is only once in every 275 years, these old Indian legends don't work out too well. But in this case, they had stationed a observer on top of the mound, and he was the one that sounded the initial alarm. Next slide, please. These pictures were taken by a man in the west part of the city. For the first 4 pictures were taken from his yard, and then the last 2 pictures from his basement. When I saw him later, I asked him if the storm had affected his house any. He said, well, really, I don't know. When I find it, I'll let you know. So if I may have there's the beginning of it to the west. The next slide, please. The winds in a mature tornado are estimated to be in the vicinity of 400 miles an hour. We do not have any actual measurements. We have no instruments that can stand up to these velocities. And we've had to use indirect evidence such as measuring the damage from freight cars and telephone poles. Next slide, please. This was from a warning standpoint, this tornado was a nice one because it's so visible. Many of them are hidden by obscured clouds and people don't see them till actually they're hit. Next slide. Next slide, please. Now he'd gone to the basement, and this happens to be some screening in front of his casement window. Next slide, please. And from then on, that was his last picture. Well, we have he survived it nicely, actually. I have a film that was just recently prepared by the Weather Bureau. Part of it was shot in Kansas City, and part of it in the east, and it uses all of the tornado footage that we've been able to gather through the years. One of the problems that we have in the tornado footage is, for some unknown reason, these photographers don't seem to stand still very, very long. So next time there's a tornado watch, strap yourself to a tree someplace and get a tripod. We'll give you $15 or $20 for the film. So if I could have the movie, please.
My spot on the stage, and I think those of you out there looking at it more direct must have a good idea of what the important responsibilities are of these weathermen, particularly Mr. Pearson and his staff. Weather is an all-day and a forever going process, so these weathermen, like Mr. Pearson and people at Kansas City, are always on duty, and we certainly appreciate him taking time off to visit us, because right now there may be some weather developing that he should be working with. At 11 o'clock, there will be a discussion period for our speaker, Mr. Pearson, and the speaker following. And we have changed the discussion session from English building to the Physical Science Math building, room 103. Physical Science Math building is out front from the auditorium and to your right, next to the Arts building. In the front part of the Physical Science building, room 103, we'll have a discussion period where you might ask Mr. Pearson questions or discuss anything further about the weather with him. We appreciate very much your attending this session. Now,